Similarly, like we have revised the concept of distance time graph, we need to revise the concept of speed time graph also. At the present moment, I'm dealing with the scalar quantities graphs, distance time graph and speed time graph, and later on I'll teach you how or what is the difference between distance time and displacement time graph, and what is the difference between speed time and velocity time graph,
Sir, is
which will
this a
be a
speed
part of
time
our.
graph?
But at the present moment, we are going to deal with the speed time graph, Hamza.
Okay, sir, this is not a velocity time graph.
No, this is not a velocity. Take it as speed time graph.
Okay, sir.
Okay. So right, if this is a speed time graph, so we have plotted on the y-axis the value of speeds and on the x-axis the values of time. Right, G?
Yes, sir.
The graph is a straight line. This straight line is giving us some value of speed. When we have started our stopwatch, when we have started calculating the data, started to collect the data from the moving object, the moving object was not at rest at that point. It does have some value of speed. As an example, suppose this particular point is at 10 meter per second. Okay, Hamza?
Yes, sir.
So the object was actually moving with a speed of 10 meter per second when we have started our stopwatch. So that's why we have taken the first point as 0, 10 means 0 at 0 seconds, the speed was 10 meters per second. So now tell me, what does this straight line means? Or what kind of motion was being produced by the moving object so that our recorded data, the recorded data of our tabulated data has given us such kind of graph. What kind of movement was being performed by the moving object? Can you guess about that movement, Hamza?
Um, Sir, instantaneous acceleration.
No, no. That particular object must be covering the equal, must be moving with the equal change of speed per second. First of all, this graph is a straight line. Okay?
Yes, sir.
And this particular straight line is not parallel to the x-axis. Okay, Hamza?
Yes, sir.
A straight line not parallel to x-axis means that as the time is passing by, the speed of the moving object is increasing. Are you agreed with it?
Yes, sir.
Okay, G. The speed of the moving object is increasing with the passage of time. And is this increase equal in equal intervals of time?
Yes, sir.
So, by applying the concept of gradient here, we can say that the object is moving with constant acceleration, Hamza.
Yes, sir.
What is gradient here? As an example, in case of distance time graph, the gradient was speed. In case of displacement time graph, later on we'll prove that the gradient will be the velocity. Now, what can you say about the gradient of speed time graph?
Um,
Once
Sir,
again, by applying the same concept, Hamza, y2 minus y1 over x2 minus x1 means change in the quantity plotted on the y-axis per unit change in the quantity plotted on the x-axis. By applying this concept in the present graph, we can say change in the speed of the moving object per unit change in the time. The change in the speed per unit time will be equals to the magnitude of acceleration. Can I say the magnitude of acceleration instead of saying the word acceleration, Hamza?
yes, sir. Because we
Why
do
have
not
I
have.
used the word? Huh?
So that is because we do not have the acceleration, and this is sorry, we do not have the direction. It is not a velocity time graph, so it cannot be directly be the acceleration.
Shabash, shabash. We are dealing with the speed time graph instead of velocity time graph. So if we are dealing with a speed time graph, then we can say that the magnitude of acceleration will be obtained from the gradient of the straight line or gradient of the graph. Right, Hamza?
Yes, sir.
So once again, you can see we are obtaining three different informations from the graph. The one information about the y-axis, which is actually the speed here. The one information of the x-axis, which is actually time here. The one information can be obtained from the gradient of the graph, which is actually the magnitude of acceleration here. And I can say this magnitude remained constant. Why this magnitude of acceleration remained constant, Hamza?
Sir, because the gradient is constant.
Because the gradient is constant, because the object clearly, the data of the object must be of the type of that the object was covering, was changing its speed equally in equal intervals of time. Right, Hamza?
Yes, sir. Sir, but since this is at not starting from the origin, so what will we say about it?
Now, in this case, we don't have any reference point from where the body is moving. Because it is, Hamza, it is not necessary that every graph is going to give us every information. It is not necessary.
Yes, sir.
Sometimes some informations can be obtained from one graph but cannot be obtained from other graphs. I can quote you an example. Later on, you will see with me, you must have studied it in O levels concept also, that by calculating the area between the graph line and the timeline, in case of speed time graph, you can calculate the distance covered by the moving object.
Yes, sir.
Okay, this is the property of speed time graph. You can obtain the information of the fourth quantity also from it. But this property cannot be applied on distance time graph or displacement time graph. So it is not necessary that every information which can be obtained from one graph can also be obtained from other graph.
No, no,
Similarly,
sir.
we can obtain the information of the reference point. We can include a reference point in order to plot the distance time graph, but in case of velocity time graph, the, the information of reference point is not necessary.
नहीं सर
Are
मैं
we on
ये
the same page?
नहीं सर मैं ये पूछ रहा हूँ कि सर क्योंकि ये एक मतलब वैल्यू पे जैसे हमने कहा था 10 है एग्जांपल के तौर पे 10 से शुरू 10 मीटर्स पर सेकंड से शुरू हुआ है
Hmm.
वाई एक्सिस
हाँ,
पे क्योंकि ये जीरो पे नहीं है
दे-
जीरो पोजीशन पे नहीं है
इसलिए बेटा कि बॉडी वॉज नॉट एट रेस्ट व्हेन द स्टॉप वॉच वॉज बीइंग स्टार्टेड. अगर मैंने जब स्टॉप वॉच चलाई थी उस वक्त अगर ये ऑब्जेक्ट रेस्ट पे होता और उसी वक्त इसने अपनी मूवमेंट शुरू की होती तो ये ग्राफ स्ट्रेट लाइन बनता और ओरिजिन से ही चलता.
ठीक सर मैं ये पूछ रहा था
ठीक है, मतलब आपका जो इनिशियल रेफरेंस पॉइंट है, व्हेन यू हैव स्टार्टेड योर स्टॉप वॉच, व्हेन यू हैव टेकन योर फर्स्ट रीडिंग, व्हेन यू हैव नोटिस्ड योर फर्स्ट रीडिंग, at that time the speed was 10 meters per second as an example. At that time the speed was not equal to zero, so that's why the graph is not being starting from 0 0.
सर so we can say that the object was in motion before time started
Yes, object was already in motion. Object was moving in front of our eyes, and suddenly we are being asked to notice its value of speed. So the very first reading which we have taken was equals to 10 meters per second, suppose.
okay sir
Right? Okay. Yes, if the object will be at rest when we have started our stopwatch, if the object is just moving, if the object has just started its journey when we have started our stopwatch, then the speed time graph will definitely begin from 0 0.
okay sir
Right? Our next graph is the graph of two bodies, two objects, body A and body B. So clearly, the slope of body B, the slope of the graph of body B is larger as compared to the gradient of the graph of body A. So we can say the body B is moving with a greater acceleration as compared to body A, Hamza. Can we say that?
yes sir
Okay. And once again, both those bodies were moving with a speed of, as an example, 10 meter per second. Both those bodies were not at rest when we have started noticing their movement. So that's why their graph is beginning. The graph of both is beginning from the value of 10 meter per second, 10 meter per second, instead of from 0 0. Is it okay, Hamza?
yes sir
Right, G. The velocity is constant. Therefore, acceleration equals to zero. The velocity is constant. Therefore, acceleration is equals to zero. What does it mean, Hamza? What is being stated by the last graph? What kind of movement can we interpret about that particular body for which this graph is being plotted?
So that the speed is constant and not increasing. It is maintained at a certain value.
Yes, speed is not increasing, speed is not decreasing. So that's why the graph is a straight line parallel to x-axis. Graph is a straight line parallel to time axis, right?
Yes, sir.
And when the speed is not increasing, speed is not decreasing, such kind of motion was definitely happening with zero acceleration, Hamza.
Yes, sir.
What is the definition of acceleration, Hamza?
So the change in velocity per unit time.
The change in velocity
Per
per
unit time.
unit time. Can you differentiate between acceleration and deceleration or retardation?
Yes, sir. Acceleration would be the rate of increase in velocity per unit time, and retardation or deceleration would be the rate of decrease in velocity per unit time.
Rate of decrease of velocity per unit time. Okay, ठीक है. And what is the difference between increasing acceleration and decreasing acceleration, Hamza?
So that in both cases, the acceleration is not constant. When increasing acceleration and the amount of acceleration is larger in each next time interval, but in decreasing acceleration, the acceleration is decreasing in each next time interval.
In every next equal time interval, in every next equal time interval, the change in speed of the moving object is lesser as compared to the previous time interval, then it means that body was performing or was moving with decreasing acceleration. Am I right, Hamza?
Yes, sir.
And if in every next equal time interval, if the object, if the body is changing its speed, if the speed of the body is changing more, is changing larger as compared to the previous equal time interval, then we'll say, or then we'll definitely obtain the graph which is called the increasing gradient graph, Hamza.
Yes, sir.
Later on in this chapter, we'll also see the decreasing gradient and increasing gradient graphs also, inshallah. तो वो भी हम देखेंगे. जी हमजा,
Yes, sir.
we can also calculate, we can also determine the distance covered from the area under a speed time graph. How can we calculate the distance covered from the area under a speed time graph, Hamza? How can we calculate the distance covered from the area under a speed time graph? Do you have any idea?
So the time when put in a mathematical equation, it will be meters per second into the distance covered uh, over time into time. So the time will cancel out, and we will have the distance.
Shabash, you are trying to justify that if the quantity plotted on the y-axis, when the quantity plotted on the y-axis, which is actually a speed, is being multiplied with the quantity plotted on the x-axis, which is a time in this case. So when if speed equals to distance over time, then definitely the distance has to be the product of speed and time. That's you were trying to justify.
Yes, sir.
Yes, obviously, this can be justified, and the two quantities which are being plotted on the y-axis and plotted on the x-axis in case of speed time, when are being multiplied together, so the answer obtained will be an answer for the quantity which is actually being obtained by multiplying speed with time. And when we multiply speed with time, this particular product is always equals to distance covered. Yes, you were trying to say it by the help of units, meter per second into second, second से cancel out हो जाएगा, तो it becomes meter, that's why it's a distance. Yes, आप इस तरह से भी इसको आंसर कर सकते हो हमजा. So it is the property
सर लेकिन इसकी
of the
theoretical
speed time graph. जी हमजा.
सर इसकी मतलब जो आपने पूरी मतलब स्टेटमेंट वाली डेफिनेशन दी है
हम्म,
थियोरेटिकल जो है वो फिर से रिपीट कर देंगे.
जी जी मैंने ये कहा है कि in order to calculate the area of the speed time graph, actually we are multiplying speed with time. If speed equals to distance over time, then by cross multiplying it, we can obtain, by making d as the subject of the formula, by making distance as the subject of the formula, so distance becomes equals to speed into time. So whenever speed and time times product is being calculated, actually we are calculating distance covered, because when speed is being multiplied with time, it becomes equals to distance. By definition, you know speed equals to distance over time. Is it okay?
यस सर.
If speed equals to distance over time, so it means that when speed and time are being multiplied together, it becomes equals to distance covered. So whenever you will be calculating the area, actually you are simply, or any student simply is multiplying the quantity which is being plotted on the y-axis with the quantity which is being plotted on the x-axis. And actually we are trying to calculate the product of the two quantities. One is plotted on the y-axis and one is plotted on the x-axis. And that particular product, in this case, is specifically becomes equals to distance covered. So that's why it is a distance covered answer.
ओके सर.
Right?
यस सर.
लो हमजा आज के लिए इतना.
ठीक सर.
मैंने आज कहीं